Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 6.1, Problem 7. This is Section 6.1, Problem number 7. It says, consider the experiment of rolling a standard pair of dice. A, construct a probability distribution for the possible outcomes. So a probability distribution, we're looking for a chart with two columns. The first column is going to list every possible value of your experiment, and the second one lists the probabilities. So to start this off, we're going to have, let's put it here, x, probability of x. So now if I roll a pair of dice, what are all the possible outcomes? Well, the lowest roll I can get with a pair of dice is a 2. It's 1, 1. I can get a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, an 11, or a 12. 12 is the biggest roll you can get when you roll a pair of dice. That's 6. So that's the first column. 2 through 12 is every possible result you can get when you roll a pair of dice. Now we have to fill in the probabilities. Where's that going to come from? I mean, the first problem, you know, we think about it a little bit, but how about the probabilities? Well, it helps if you can remember what that dice chart looks like, what every possible roll is that you can get when you roll a pair of dice. Let's see if I can, I don't know if I can fit it here. I'll write it kind of small so you can get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. And then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And then finally 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So that's every possible roll you can get when you roll a pair of dice. A lot of people refer to that as the dice chart. It lists all the rolls you can get with a regular pair of dice. Now, given that, what's the probability of rolling a 2? The only roll that gives you a 2 is a 1, 1. There's only one such roll out of 36 possible rolls. So the probability of rolling a 2 is 1 over 36. I can reduce these or turn them into decimals. I'm going to leave all the denominators the same. It's going to make some of the computations a little easier later on. How about getting a 3? What's the probability of rolling a 3? Well, there's 2 rolls that give me a 3. Out of all the rolls there are, there's 2 of them that give me an answer of 3 on the dice out of 36 rolls altogether. So the probability of rolling a 3 is 2 out of 36. 2 rolls do it out of 36 rolls altogether. How about the probability of getting a 4? Well, there are 3 rolls that give me a 4. 3, 1, 2, 2, and 1, 3. So 3 out of 36. There's 3 different rolls out of 36 altogether that will give me a 4. For a 5, and then the totals go along these diagonals, there's 1, 2, 3, 4 different rolls that will give me a total of 5 on the dice. So 4 rolls out of 36 altogether gives me an answer of 5. A 6, there are 5 rolls, 1, 2, 3, 4, 5 rolls that give me a total of 6. So the probability of getting a 6 is 5 out of 36, 5 rolls out of 36. 7, people who gamble with dice, that's the roll that will make you win or lose. A 7, 1, 2, 3, 4, 5, 6 different rolls that make a 7. So 6 ways to get a 7 out of 36 rolls altogether you can get. An 8, there are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 rolls that give you a total of 8. So 5 out of 36. That's the probability of getting an 8. A 9, they're starting to go down in number now. So getting a total of 9, there's 1, 2, 3, 4 rolls that give me a total of 9. Total of 10. There's only 3 rolls. 6, 4, 5, 5, 4, 6. Those 3 give me a total of 10. So there's 3 rolls out of 36 altogether. Probability of getting an 11. There's only 2 rolls that give me an 11, 6, 5, and 5, 6. So 2 rolls out of 36 altogether give me an 11. And finally a 12. 12 is unlikely. There's only 1 roll out of 36 that gives you a 12, which is 6, 6. Or some people call it boxcars if they play with dice a lot. There's your probability distribution. So for part A, we have a chart with 2 columns. The first column lists every possible result you can get for your experiment of rolling a pair of dice. And the second column, probability of x, gives you the probability for getting each one of those rolls. So that's A. B, draw the histogram. So the bar graph for this, again, histogram specifically means the bars have to be vertical. They have to touch the sort of special rules. So let's see if we can fit that in right here. Now, my biggest probability is 6 over 36. Again, I can reduce some of these, unless I can reduce them all. It's more in my best interest to keep the denominators the same. I could turn them into decimals. 1 divided by 36 equals 2 divided by 36 equals. It's a lot of extra work that doesn't give me any more information than I don't already have. So I'm happy to just leave them like this. So my number scale will go 1 over 36, 2 over 36, 3 over 36, up to 6 over 36 is the path of least resistance. One over 36, 2 over 36, 3 over 36, 4 over 36, 5 over 36, 6 over 36. And again, if you made them into decimals, you could go like 0.05, 0.10, 0.15, 0.20, 0.25 for as high as you have to go. But this is easier, and it's going to give me a good enough answer. So the first category, or first bar, has a height of 1 over 36. And the value from the first column goes right under the center of that bar, which will be a 2. Now the next bar will go to a height of 2 over 36. And the number from the first column, which is a 3, goes under the center of that bar. The next bar goes to a height of 3 over 36, which is marked there. Again, notice the bars are touching, and they are vertical. The number from the first column goes under the center of that bar. Try and make the bars the same width as much as you can. The next bar goes to a height of 4 over 36. 4 over 36. The number from the first column, which is now 5, goes under the center of that bar. The next bar goes to 5 over 36. The next bar goes to 6 over 36, which is the biggest height we'll have to deal with. Again, notice the bars touch. They're all vertical. There we go. Put the number from the first column under the center of the bar. Now the bars are going to start going down in height. The next one is 5 over 36. And that's for 8. The next one is 4 over 36. That's for 9. Then 3 over 36. That's for 10. Then next is 2 over 36. That's for 11. And finally, the last bar, 1 over 36 for 12. So the histogram is very much like a pyramid. You would say that's a symmetric shape to it. And that's the answer for B. Draw the histogram. There's the histogram for this probability distribution. Now C, find the mean. So this would be the average guess. So if you take a pair of dice, roll your dice millions of times, keep track of the results you get, and then add them together, divide by the millions of trials that you did for your experiment, what's the answer going to come out to? Now you could roll the dice millions of times and do that, but it would take you years. Or You could just multiply every number in the first column times its probability, add the results together, which will take a couple of minutes. That's a much better option. So we'll multiply every number in the first column times its probability all the way down and add the results together. So you're going to have 2 from the first column times 1 over 36. So 2 times 1 over 36 is 2 over 36. Again, I can reduce that, but looking to the future of where I'm going to have to add the results together, I'd rather have all the same denominator. So I'm happy to leave that as 2 over 36. So next, multiply the number from the first column 3 times its probability, 2 over 36. So 3 times 2 over 36, think of the 3 really as a 3 over 1. So 3 times 2 is 6. And then 1 times 36, you have 6 over 36. Again, that will reduce, but I'd rather not bother. And you write these a little smaller, just so I'll have room. Let me come up a little bit. 2 times 1 over 36. I can already see it. I'll run out of room if I go at the rate I was going. And then I'll do this one again. 3 times 2 over 36 was 6 over 36. And now I'm at 4 times 3 over 36. So really the 4 times 3 is going to give me a 12. And for the bottoms, the 4, it's not written, but it's really a 4 over 1. So the bottom, 1 times 36, 36. Again, that reduces very nicely to 1/3, but I'd rather keep everything over 36 because I'm going to have to add the numerators together, and it will help me to have a common denominator. The next one, the number from the first column is 5 times this probability is 4 over 36. So 5 times 4, I'm going to have 20 over the bottom is 36. The next one down, the number from the first column is 6 times this probability is 5 over 36. So 6 times 5, you'll have 30. And again, under the 6 is a 1. 1 times 36 is 36. And then the next one down, the number from the first column is 7 times this probability is 6 over 36. So the 7 times 6 is 42. You have a denominator of 36. Then the next one down is 8 from the first column times this probability is 5 over 36. So 8 times 5 is going to give you a 40 for the top over 36. And it's getting closer. So now the number from the first column is 9 times this probability is 4 over 36. 9 times 4 is 36 over 36. Now as nice as that does reduce, 36 over 36, again, I want to leave everything with the same denominator. A little closer to the end, the number from the first column is 10 times this probability is 3 over 36. 10 times 3 is going to give me a 30 for the numerator. Denominator, again, stays 36. The next row down, the number from the first column is 11 times this probability is 2 over 36. 11 times 2, I'm going to have a 22 in the top. As always, 36 in the bottom for this problem. And finally, the last one, the number from the first column is 12 times its probability, which is 1 over 36. So now 12 times 1 is 12, and the bottom is still 36. So I have a lot of fractions, but they're all over 36. So I'm going to add these together. I know the common denominator is 36. So I'm going to add the tops. 2 and 6 is 8. 8 and 12 is 20. 20 and 20 is 40. 40 and 30 is 70. 70 and 42 is 112. Plus 40 is 152. Plus 36 is 188. Plus 30 is 188 and 30 is 218. Then I'm going to have 240, and then 252. Now, you'd like to reduce this if you can. 252 over 36, that's the mean. They're both even. You can cut them both in half. So half of 252 is going to be, let's see, 156. No, 176. Well, I know the answer comes out to 7. So you could just as easily do 252 divide by 36 equals. And the calculator will tell you pretty quickly it's 7. So that's the mean. The mean is 7. So now the variance is going to come from filling in that really big chart. So we have to set up the chart. I'm going to move over a little bit. So one column will be for x, and I'll have x minus mu, and the mu, again, fortunately, is a whole number. It's 7. Then x minus mu in parentheses to the second power. Then x minus mu in parentheses to the second power times probability of x. So x are all the different outcomes you can get for your experiment, 2 through 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are all the different rolls you can get with a pair of dice. So now what I'm going to do, from each value of x, I'm going to subtract away 7, because that's what you have to do for the second column. So in the top row, x minus mu, x is 2 minus mu is 7. 2 minus 7 is negative 5. The next row down, x is 3 minus mu is 7. 3 minus 7 is negative 4. The next row down, x is 4 minus 7. 4 minus 7 is negative 3. The next row down, x is 5 minus 7. 5 minus 7 is negative 2. The next row down, x is 6. 6 minus 7 is negative 1. Next row down, they're both 7. X is 7, mu is also 7. 7 minus 7 is 0. I'll make the computation for that row easy. Then next row down, x is 8. 8 minus mu, 8 minus 7, that's 1. Then x is 9. 9 minus mu is 9 minus 7, that's 2. Then x is 10. Minus mu is 7. 10 minus 7 is 3. Then next x is 11. 11 minus mu is 11 minus 7, which is 4. And finally, x is 12. 12 minus mu is 12 minus 7, which is 5. So now, the next column, what I have to do is take the results for x minus mu that I got, and every row raise those answers to the second power. So in the top row, x minus mu is negative 5. So I do negative 5 second power. Negative 5 times negative 5 is positive 25. The next row down, x minus mu is negative 4. So negative 4 second power. Negative 4 times negative 4 is positive 16. The next row down, x minus mu is minus 3. So minus 3 second power. Minus 3 times minus 3 is 9. The next row down, x minus mu is negative 2. So negative 2 second power. Negative 2 times negative 2 is 4. The next row down, x minus mu was negative 1. Negative 1 second power. Negative 1 times negative 1 is positive 1. Then the next row down, x minus mu was 0. So 0 second power, 0 times 0 is 0. That's pretty easy. Then x minus mu was 1. So 1 second power, 1 times 1 is 1. Then next x minus mu was 2. So 2 second power, 2 times 2 is 4. Then x minus mu was 3. 3 second power, 3 times 3 is 9. Then x minus mu was 4. 4 second power, 4 times 4 is 16. And finally, x minus mu was 5. 5 second power, 5 times 5 is 25. So now what I have to do for the last column is take the x minus mu second power answers I got in the previous column and multiply each one times the probability for that row in the original probability distribution. So in the top row, x minus mu second power is 25 times the probability for rolling a 2. So way back from the probability distribution, that's 1 over 36. So 25 times 1 over 36 is 25 over 36. And next, we have x minus mu is 16, or x minus mu squared rather, is 16 times this probability. So the probability of rolling a 3, if I look back at the original probability distribution, is 2 over 36. So 16 times 2 over 36 is 32 over 36. And then x minus mu second power is 9 times the probability of rolling a 4. So if I look back, the probability of rolling a 4 is 3 over 36. So 9 times 3 over 36 would be 27 over 36. And the next row down, the x minus mu second power is 4 times the probability in this row was for rolling a 5. So if I look, the probability of rolling a 5 is 4 over 36. So 4 times 4 over 36 is 16 over 36. And then the next row down, x minus mu second power is 1 times the probability of rolling in this row is 6. So that's 5 over 36. So 1 times 5 over 36 will be 5 over 36. Now the 0 will be easy. X minus mu second power is 0 times the probability now of getting a 7. If I look back at 6 over 36. So 0 times 6 over 36 is just plain old 0. And the next one, x minus mu second power is 1 times probability of x for getting an 8. So if I look for getting an 8, it's 5 over 36. So 1 times 5 over 36 is 5 over 36. And the next row down, x minus mu second power is 4 times probability of, in this row, getting a 9. So if I look, probability of getting a 9 is 4 over 36. So 4 times 4, you're going to have 16. It will be over 36. And now the next row down, the x minus mu second power, the answer for that is 9. And times probability of x in this row of getting a 10 would be 3 over 36. So 9 times 3 for the top is 27. You have a 36 in the denominator. And now the next one down, the x minus mu second power is 16 times the probability of x for rolling an 11 would be 2 over 36. 16 times 2 is 32. The denominator is 36. And finally, x minus mu second power is 25 times probability of x for the bottom row of rolling a 12 would be 1 over 36. And 25 times 1 for the top is 25. The denominator is 36. So now we filled out the whole chart. What we have to do to get the variance is get a total of all the answers in the last column. That's why I wanted to keep the common denominator. Even though a lot of these would reduce nicely, now I'd have to go back and make common denominators anyway. Why go in a circle? I already have the common denominators. So really, as I add these up, I know the bottom of my answer is 36. Let me put that in immediately. Now I can add the top. 25 plus 32 plus 27 plus 16 plus 5 plus 0 plus all the way down. So the calculator will help me with that. 25 plus 32 plus 27 plus 16 plus 5 plus 0, and then I'm going to add the same numbers so I can double what I got so far. So if you add all of them up, it comes out to 210 over 36. So now that does not reduce to a nice whole number, unfortunately. So 6 will go into both evenly. So 210 divided by 6 is 35. So 6 into 210 is 35. 6 into 36 is 6. 35 over 6 doesn't reduce anymore. You can write it as, let's see, that would be 5 and 5/6 if you would rather have it in that form, so less than 6. Or as a fraction, like if you go off to the side and just go with your calculator, 5 divided by 6 equals, it would be 5.833333333. The 3's run forever. So the variance is 5.8333333. Now the standard deviation, which they usually tend to ask, is the square root of whatever the variance is. So the square root of 5.8333333. And let me do that with the calculator. And the calculator says that is 2.415229458. So less than 2.5 for the standard deviation.